Hello everyone, welcome back. In the previous video we discussed about the horizontal projectile motion. Now in this video we will be discussing about the projectile motion from the top of the tower. When you throw it upward into the air is one case, and the next video will be coming up with a projectile which is thrown downward making an angle theta with the horizontal. In this video, if there is a particle that is thrown into the air making an angle theta with the horizontal, we are supposed to calculate what the height of the tower will be, or range of the tower, range of the horizontal projectile, or range of the projectile, which is that horizontal displacement, and the velocity with which it will be striking the ground, and the angle with which it will strike the ground. These are the terms that we are supposed to calculate in this case. So for the calculation of time, also one more thing, we are supposed to calculate the time for the particle to reach the ground. This is one more thing that you have to calculate. The first thing is time taken by the body to reach the ground, height of the tower and the range of the projectile, velocity with which the body strikes the ground, and the angle with which it will be striking the ground. So here I am taking the sign conventions to be all the whatever the measurements that I make vertically upward, I take them to be positive. Towards the right, I take them to be negative, and towards the negative y-axis, I take them to be negative. Towards the negative x-axis, I'll take them to be negative. A very simple rule I follow. And now in this case, first calculation of the time taken for the particle to reach the ground, what we use is we use this equation of motion, which is using Sy is equal to uy into t plus half into ay into t square. Here Sy is the vertical displacement that will be measured downward, so we take it minus h. Uy is upward, so along the direction of motion we take it as u sine theta, which is positive. And ay, which is the acceleration due to gravity will be always acting downward, which is minus g, and I replace the t with the capital T. And substituting all the values, what I get here is minus h is equal to u sine theta into capital T minus half into g into capital T square. So taking the LCM 2, and if you simplify, 2h is equal to 2u sine theta into capital T minus gt square, and I get here equation, a quadratic equation in terms of t, which is gt square minus 2u sine theta into t minus 2h is equal to 0. Now if we solve the above equation, solving for capital T, we get the t value is equal to the time taken by the particle to reach the ground is equal to, we get it as u sine theta, u sine theta divided by g plus r minus root over u square sine square theta by g square plus 2h by g. From the same, I can even calculate the height of the tower from this equation here. What I can do is very simple. If I have to calculate the height of the tower, just h will be written as h is equal to minus u sine theta into capital T plus half g t square. So the height of the tower we know now, but height of the tower is coming out to be, that half the tower is h is equal to minus u sine theta into the total time t plus half gt square. And then the second, this is the question B actually. So in question B only, we already have one more term to be calculated, which is range of the projectile. Range of the projectile is equal to, what is it? Horizontal displacement is what we call the range as. So horizontal displacement will be due to the horizontal component of velocity, which always remains the constant. So that means if the velocity is constant along the horizontal, that means the acceleration along the horizontal will also be equal to 0. So the range, I can directly write it as r is equal to the horizontal component of velocity into the total time. So the range of the projectile is equal to u cos theta into t. So calculating the t value, you can calculate the range itself here. So that range I can write it as u cos theta into capital T. Now what we are supposed to calculate is, we are supposed to calculate the velocity at the point where it will strike the ground. So at that point I consider the velocity as v bar is equal to vx I cap plus vy j cap. And here if you observe, the horizontal component, as I already told you, will always remains the constant. So that means Vx will always be equal to Ux cos theta. So I wrote it as V cos alpha because if I'm provided with the value of alpha and I'm provided with the value of V, I can calculate the V horizontal component easily. But anyway, we can calculate the alpha value also here. So for that, I just take Vx is equal to V cos alpha, which is equal to u cos theta. If you're supposed to calculate cos alpha, you can directly even calculate using the, if you're provided with u and theta, you can calculate the alpha value also if you're provided with v. So in that case, what I get here is Vx, I simply can write it as Vx is equal to Ux, which is equal to u cos theta, which remains the constant, the first thing, and the Vy value is to be calculated. So for this calculation of Vy, what I use is, I use the equations of motion. What equation of motion I use is, I know the time. You can use the equation of motion in terms of time also, or I just use it very simple way. I use using vy square plus, sorry, vy square minus uy square is equal to 2 into ay into sy. So here vy is to be calculated. So uy, you take it as u sin theta, and ay you take it to be equal to minus g, and sy also you take it as minus h. Substituting these values, I get vy square minus u square sin square theta is equal to 2gh, and the component is vy is equal to root of u square sin square theta plus 2gh. Now the velocity will be v bar is equal to u cos theta into I cap plus vy value is root of u square sin square theta plus 2gh into j cap. So what will be the magnitude of this velocity? Magnitude of the velocity will be equal to v, I can write it also as root over, as these two are perpendicular components, the angle between them is theta is equal to 90 degrees. So we use the parallelogram law of vector addition, which is resultant of any two vectors is equal to p square plus q square plus 2pq cos theta. Here two vectors are vx and vy, so I just write it as vx square plus vy square plus 2vx vy cos 90 degrees. So cos 90 is 0, so the whole term becomes 0 here. So velocity will be equal to u square cos square theta plus root and the square gets cancelled, u square sin square theta plus 2gh, from which I can write the v value as u square plus 2gh, because if I take the u common out here, sorry, u square common out here, I'll remain with sin square theta plus cos square theta, which is 1. So this is the magnitude of the velocity at the point where the body will be striking the ground. Even you can calculate the value of velocity in terms of time also, but not necessarily needed. You can use this method only to calculate the velocity of the particle in terms of height of the tower, because height of the tower in most of the cases will be provided with the height of the tower. So you can calculate using this height of the tower also. And there is one more thing that we are left with. What is that? Is the angle with which it will strike. So here the angle with which it strikes the ground is alpha. I consider the let the angle, you can say let the angle with which it strikes the ground is alpha. So if you observe in this diagram, so I can directly write the value of tan alpha like this. What I can write here is tan alpha value is equal to opposite by adjacent. So in that case, I can write it as tan alpha is equal to, tan of alpha is equal to, I can write it as Vy by Vx. So tan alpha value will be equal to Vy value we know and Vx value also we know. So that means I can write it as root over u square sin square theta plus 2gh is the Vy value, and Vx value is Ux, which is equal to u cos theta, and the alpha value will be equal to tan inverse of root of u square sine square theta plus 2gh divided by u cos theta. So this is the alpha value, that is the angle with which it will strike the ground. This is the velocity with which it will strike the ground, the projectile, and this is the range of the range attained by the particle, and this is the height of the tower. And here the time can be calculated using this relation here. So whatever is asked here in this question we have calculated. So in the similar model questions we can have only one to be asked. They can just ask you the range to calculate, or they can ask you only the velocity to calculate, or they can ask you the, they'll provide mostly in the case of all the cases, in all the cases they'll be providing you the height of the tower. They can also ask you the time. So hope you understood this solution, and we are coming up with one more video which is more on a body projected downward like this, making an angle theta with the horizontal. So this again will be coming up with next video. So hope you understood everything. If you have any doubts, please do comment, and I'll see you in the next video. Thank you.